All right, so from yesterday's lesson, we talked about the formula was x plus or minus something squared plus y plus or minus something squared, and that equaled the radius squared, right? So that's what we're plugging in here. So the first one is going to be x what? X plus 1, very good. What? Squared plus y what? Minus 7 squared equals, and how'd you get 196? 14 and squared it. Remember, it's the opposite of whatever's in these bubbles. Next one, you should have done x minus what? Or plus 0, but really, I wouldn't write it like that. I wouldn't write it like that. What would I really write it as? X squared, because what's x minus 0 going to be every single time? X plus y what? Minus 9 squared equals, timeout. This is the diameter. What do I have to do with the diameter first? Divide it by. So my radius is actually 9. Then you take 9 and square it, which is 81 should have been your answer. So that should be what your equation looks like from the second one. No, 9 is your radius. The circle formula is r squared. Questions, yes or no? Do you guys remember this from yesterday? All right. All right, so what is the radius and the center of a circle? It's supposed to be squared. What is the center? -2. Good. Right here, it's the opposite of that. And it goes with the x. And opposite of this goes in the y. So -1, -2, -1. Does that make sense for a center? What is my radius? No, we don't change it to a decimal anymore. We're going to leave. We're okay with square roots. What is it? Square root of 3 is what we're going to leave it as. We don't have to change it to a decimal. We're okay with it looking like that. Make sense, yes or no? Because remember, this is what? 3 is what? It is the r squared. I don't want r squared, so how do I undo that? You square root, there's where the square root of 3 came from. Oh, this is the square root of 3 right back here, right? Yeah. All right, so circle R has a radius of 3 square roots of 3 and a center of 2, 4. Does the point 6,3 lie on the circle? Well, yesterday I came up with a weird beginning. It wasn't really geometry related, right? Because math all works together. We said if I gave you an equation and then I graphed that equation, and yes, there are equations that graph and they look like this. What do you know about any point on this graph? What will any point on this graph do to the equation? That means you could take that x and that y, you could plug those into the equation and the equation will work. What happened if you put any point that's not on the equation? What would it do if you put this x and this y into the equation? What would it do? Make it false. All right, so what do I need first? I need an equation. Then once I get the equation, I have to see does 6,3 make the equation true or false? Then I'll be able to tell whether it's on the graph or not. Do you follow me, yes or no? Well, let's make an equation first. The equation looks like x what? This is the center. X what? minus 2 squared plus y. Brody, what's the next one? Y minus what? Nope. Here's the center. So it'd be y minus 4 squared equals, what's it equal? Ah, no, close. Nope. It would be 3 square roots of 3 what? Squared. Well, let's deal with this on its own. What does it mean to square something? This is how I want you to start thinking. So this means 3 square roots of 2 times 3, oh sorry, square roots of 3 times 3 square roots of 3. Sorry. What does it mean to have 3 square roots of 3? 3 times square root of 3 times 3 times square root of 3. Why did I write it like that? Because multiplication is commutative, which means I can do 3 times 3 first, which is what? And then I want to do the square root of 3 times the square root of 3, because what happens anytime you times something by itself? What is 5 times 5? Don't tell me 25. It's 5 squared. What's x times x? So what is the square root of 3 times the square root of 3? Square root of 3 squared. And what happens with the square and the square root? And then that's 9 times 3. Because the square and the square root cancel out, leave me with a 3. Yes or no? What's 9 times 3? So there's my equation. What was the whole point of me getting the equation? Does 6,3 lie on it? If it's going to lie on it, 6,3 should be able to be plugged in for the x and for the y, and it should make it true. 6 minus 2 squared plus 3 minus 4 squared. Does that equal 27 is the question. 4 squared plus negative 1 squared. Do you equal 27?
No, because there's a negative square root.
No, that's okay.
Or negative square. Okay.
That's okay to, yep, negative square is okay. Negative square root, you're right, not. 16 plus 1 equals 27. Does 17 equal 27? No, it does not. So is this part of this circle? No, it's not.
Basically, what it is in algebra.
All right, here we go. So today's lesson, I'm actually going to go back and review stuff from algebra, and then we're going to put it together for geometry with circles. So right now, don't worry about circles. I just need you to understand this algebra. All right. Riley, what does that mean? What does that mean? What can you do with the 2? That is a common mistake, especially when I ask the question like that. You cannot distribute the 2. Now, do I understand why students get this mixed up? Do those 2 things look similar? Yes. What are you supposed to do with the 2 here? You are supposed to distribute it. However, what did I just finish saying? When you square something, what does that mean? So doesn't this mean that it should be x plus 3 times what? All right, what does it mean when I have x plus 3 times x plus 3? Okay, so you go x times x, which is, and you go x times 3, which is 3x. 3 times x, which is another 3x. We're going to pay attention to that in just a minute. And then 3 times 3, which is so what does it mean for two things to be equal, guys? Yes. What does it mean when I see this? What could I do instead? I could write this. What happens when I see this? What could I do? I could write this. We are very good at figuring out how to go forwards. What we are not always the best is taking this and being able to rewrite it like that.
Dang, you're doing some really perfect ellipses.
I'll be here all day.
Doing little.
Just that's how I practice them at home. That's what I do in my free time. Just practice drawing the ellipse. All right. Do you understand what I just said? In math, when two things are equal, we can take them out and substitute them in for other things. In fact, in Algebra 2, if you have me, you will hate me saying this phrase because I say it all day long. It's all about changing the way things look, but not their value. That means this right here doesn't look the same as that, but they have the same value, which means I can take this out and put this in its place, or on the contrary, I can take this out and put this in its place when it's necessary. Sometimes I like this form, which is called factored form. Sometimes I use this form, which is called standard form. They both are good in their own situations. But most of the time, when they give me this, I really need to work with this form. This form is going to be better, so I'll change it. And a lot of times when they give me this form, I need to change it to this form because this form is better for the situation I'm in. Does that make sense, yes or no?
Sorry.
All right, so can you help me come up with a pattern so we don't have to do this? Foiling is maybe a word you've heard, but I like distributing as a better word. Does anyone see a pattern here? Look at this first number. Here, I'll write it so it's a little easier. This was the answer. Anyone see how you can get from here? What did you do to this number? Squared it, right? So you take this number and you square it, and that gets you that one, right? Yes or no? How do you get this back number? You took 3 and you did what to it? You squared it. So square it, square it. So those are pretty easy to get. Where the heck did this middle number come from? Can you see a pattern? So these two multiply together. So what's 3 times x? Double that. So take those two, multiply them together, and then double it. And you'll get your middle term. Does that make sense? Let's try then. Let's try the fast way. What's that going to turn into? X squared. Good. Good. Plus 8x. How did you get the 8x? 4 times x is what? 4x doubled is, and that's where the middle one came from. And then plus what? 16. How did we get that? We squared that back number. This is called a perfect square. This is a perfect square in factored form. This is a perfect square in what we call standard form. Yes or no?
You just did the one.
Did we?
Minus.
Oh, there's a little difference, right? Subtle differences in math suck. But because we need to recognize them. And they trip us up. All right, what's the first number still going to be? X squared. Brody. What's the last one? Last number going to be still. Why would it still be a plus 16? Because it's a negative 4 times a negative 4. Negative, negative make a. But what's the middle one going to be? What's x times negative 4? Negative 4x. And what's negative 4x doubled? Negative 4x doubled. Means you have negative 4x and negative 4x. You have a negative 8x total. Does that make sense? Yes or no? Oh, should be getting faster now. What's it going to equal? X squared plus 10x. Oh, not equals. Plus 25. Good. Go. Oh, careful. Minus 14x, right? Because that's a negative right there. That times that is a negative 7. Doubled is a negative 14x. Yes? All right, I'm going to switch it up now. I'm going to give you first parts. What number would you need back here? How are you getting that? So I want that to be a perfect square. So I want to be able to write it like that. What number would have to be back here in order for me to be able to write it like that? Why? What did you do? None, you said 10x divided by 2 is what? 5x, right? So I know there's going to be an x and I know there's going to be a 5 in here. Does that make sense? So what number would have to be back here in order for that to be true? How did we get that back number? We squared this, right? So there would be a plus 25 is what was missing in order for me to be able to write it like that. And then what would be in the middle? Would it be a plus or a minus? Because that's a plus, I know that's going to be a plus. What will this sign always be back here? You follow me, yes or no? Try again. This is called completing the square. I'm not teaching you fully. I'll teach it fully to you in Algebra 2, but this will be enough to get us through geometry.
I remember.
Yeah, you should have done it in Algebra 1, but I know it doesn't always stick. What would you need to add? And then what would be in my bubble over here? I would need to add 49. And x minus 7 is what would be in the bubble over there. Are you following me, yes or no? This is called completing the square. Why would I be teaching you something or just refreshing your brain on something that's from algebra when we're here talking about circles? Isn't this the form of a circle? What is this right here? A factored form of a what? Of a perfect square. What is this right here? A factored form of a perfect square. So what happens when I give you this? It creates a circle. I want you to give me the center and the radius. Why can't you give me the center and the radius? It's not in the form that we need it to be in to give us the radius and the center. It needs to be in this form in order to give us the radius and the center. Am I allowed to change the way things look in math? Am I allowed to manipulate things? Oh, big time. We manipulate the crap out of numbers in math. In fact, that's what we do all day. That's that idea of changing the way something looks, but not its value.
You manipulate. Isn't that what math is?
Yes. Go away.
Numbers. Things.
Right. Sometimes the form that it's in is not good, but if we change the form, now it's good.
You know what I mean? Like in reality, like if I want to.
What can I do that would help me out here? What do I need to do? What was the skill I just taught you? I called it completing the. I need to make this a perfect square so then I can put it in its factored form. Well, in order for me to do that, it's missing something. That's what we just did just a second ago. What's it missing? A plus what back here? How did you get that? Divide 8 by 2. What's 8 divided by 2? 4. Square 4. What is it? Now, am I allowed to just add whatever I want to an equation? Yes. What's the rule? Whatever you do to one side, you just have to do to the... So I added 16. Am I fair right now? No. What do I have to do? Now, is it okay for me to add that 16 in there? And what was the whole purpose of that? This is now a perfect square, which I can change the way that it's written. And now I can write it like we did just a second ago. What can I write it as? X what? Plus 4. Good. Remember, it's the square root of that. You following, yes or no? What's missing back here? Plus 25 minus 25. Always a plus back there, right? Is it fair right now? What do I have to do? Add 25 to the other side. The whole purpose of it is now so I can write it as y, be careful, minus 5. How did we know it was minus? That sign right there told me. And then this plus this is 20. 20 plus 25 is, what is my center now? -4, comma, 5, right there, and right there. Change the signs. We did, this is like the homework questions. Now it's like the homework questions I gave you the other night. What's the radius? The 45 is the r what? What do I have to do to find the radius then? But if I square root 45, remember we're okay with it looking like that, except I have to try to simplify it. 45 can be written as 5 times 9, 3 times 3. And so it can be written as the square root of 3 squared times 5. This is what we've practiced in the past. How many times does 2 go into 2? So I get 1 3 out. Sorry, 5, you don't have enough. So 3 square roots of 5. That's the same thing. 3 square roots of 5 is the same thing as the square root of 45. This is just the simplified version. And that's what they're going to be looking for. That makes sense, yes or no? Yes?